Good morning, dear children. Today we'll be starting a new lesson, that is study of compounds. C, that is nitric acid. So last class we learned how to prepare ammonia, and then in lab also how to prepare ammonia, and for commercial use how to prepare ammonia and some physical and chemical properties of ammonia. So ammonia is basic in nature. That means it can turn red litmus to blue. So that we saw when we were doing fountain experiment as well. Now let's see uh, about nitric acid. So how is nitric acid prepared and all. So molecular formula of nitric acid is HNO3. So this is the molecular formula of nitric acid, and relative molecular mass of nitric acid is 63. So how come this 63? H. Atomic mass of hydrogen is 1, atomic mass of nitrogen is 14. So as a whole 15. Then atomic weight of oxygen atom is 16. But there are 3 oxygen atoms. There are how many oxygen atoms? 3 oxygen atoms, which gives 48, and 48 plus 15 is 63. So relative molecular mass of nitric acid is 63. And this is the structure of nitric acid. That means in nitric acid, what are the atoms present? Hydrogen 1 atom, oxygen 3 atoms you can see here, and nitrogen 1 atom. So how they are combined, let's see. Hydrogen and oxygen is combined by a single covalent bond, and oxygen and nitrogen is combined with single covalent bond. But this oxygen and nitrogen is linked with double covalent bond, and this is a coordinate bond. What is this? This is a coordinate bond. And for this coordinate bond, nitrogen has shared lone pair of electron. Nitrogen has shared lone pair of electron, and here nitrogen is donor and oxygen is receiver. So this is the structure of nitric acid. Now let's see how nitric acid is prepared in laboratory. So lab preparation of nitric acid. So what are the reactants we use for preparing nitric acid in the laboratory? Potassium nitrate and sulfuric acid. So in place of potassium nitrate, whose molecular formula is KNO3, which is commonly known as niter, we can also use sodium nitrate, whose molecular formula is NaNO3, and the common name for sodium nitrate is child saltpetre. So what are the reactants we use for preparing nitric acid? Concentrated sulfuric acid and potassium nitrate or sodium nitrate. Now how do we prepare? Let's see. A mixture of equal parts. That means we need to take equal parts of the mixture by weight of potassium or sodium nitrate, and concentrated sulfuric acid is heated gently to 180 degrees Celsius to 200 degrees Celsius in a glass retort. You can see it in figure 10.1. Sulfuric acid is a non-volatile acid and produces volatile nitric acid. So for preparing hydrogen chloride gas, also one of the reactant was sulfuric acid. And for preparing nitric acid as well, we are using sulfuric acid. Why? The simple reason behind it is sulfuric acid is a non-volatile acid and produces volatile nitric acid on reacting with potassium nitrate or sodium nitrate. So you can see here, this is a retort. Okay, this is a glass retort, and in this glass retort we are putting the mixture of sodium or potassium nitrate and concentrated sulfuric acid in equal weight, equal parts. If you are taking a solution of sodium nitrate or potassium nitrate 50 ml, then we have to take concentrated sulfuric acid also 50 ml. Then when we start heating this, brown fumes start coming, and this brown fumes is collected in this flask, and since the reaction is exothermic and the gas produced is a very hot gas, so it is to be cooled by passing water outside the flask. Okay, outside the flask, the water can be collected in the straw. The water that is coming through the tap for condensing this flask is collected in the straw, and we can get liquid nitric acid here. We can get liquid nitric acid here. So nitric acid is formed in the form of vapor because it is volatile in nature. So on liquefying, we get liquid nitric acid here. So this is the process how we prepare nitric acid. And as for your syllabus, you need to see the figure diagram very carefully. Okay, diagram, reactants, and then equations and all very carefully. Then reaction. So what is the reaction that is actually taking place while preparing nitric acid? If you are using potassium nitrate or niter with concentrated sulfuric acid, and if you are heating the mixture below 200 degrees Celsius, you will be getting potassium hydrogen sulfate plus nitric acid. But if you are using sodium nitrate, then you will be getting sodium hydrogen sulfate and nitric acid. Now how is this nitric acid collected? The vapors of nitric acid are condensed to a light yellow liquid by chilling the receiver with running cold water. So how is this acid? How is the acid collected? The acid is in the form of vapor, as it is a volatile acid, and the vapor of nitric acid is condensed to a light yellow liquid by chilling the receiver with running cold water. So you need to condense the flask that is receiving the vapor. Then pure acid is colorless, but the acid obtained in the laboratory is slightly yellow. So pure acid is actually colorless, but the acid prepared in the lab is slightly yellow. The yellow color is due to dissolution of reddish brown colored nitrogen dioxide gas in the acid. This gas is produced due to the thermal decomposition of a portion of nitric acid. So as the nitric acid is formed, the nitric acid, some portion of nitric acid undergoes thermal decomposition because of the heat produced in the reaction. Okay, during the reaction, because of that heat, some portion of nitric acid breaks into water and nitrogen dioxide and oxygen gas, and because of the presence of this nitrogen dioxide, the nitric acid prepared in lab is slightly yellow in color. Otherwise pure nitric acid is colorless. And then the yellow color of the acid is removed. If dry air or carbon dioxide is bubbled through the yellow acid, the latter turns colorless because it drives out nitrogen dioxide from warm acid, which is further oxidized to nitric acid. So if we pass dry air or carbon dioxide, if dry air or carbon dioxide is bubbled through the yellow acid, then the yellow color will fade, the yellow color will go, because it drives out nitrogen dioxide from warm acid, which is further oxidized to nitric acid, and this further nitrogen dioxide can again be further oxidized to nitric acid. By addition of excess water, nitrogen dioxide gas dissolves in water, and thus the yellow color of the acid is removed. And again, one other way of removing yellow color is by adding a lot of water, which with this water nitrogen dioxide dissolves, and then the yellow color of the acid is removed. The reaction is the reverse of the decomposition of nitric acid. So this reaction is reverse of the decomposition of nitric acid. Then what are the precautions we need to follow while preparing nitric acid in lab? All glass apparatus is used because nitric acid vapors attack rubber and cork. So all glass apparatus is to be used because nitric acid vapors attack rubber and cork. That means it can corrode, it can eat, it can corrode rubber or cork. So concentrated hydrochloric acid is not used in place of concentrated sulfuric acid because HCl is volatile, and hence nitric acid vapors will carry HCl vapors. So this is the reason why we were not using nitric acid as well while preparing hydrogen chloride gas, because both are volatile in nature and they may mix up with each other while preparing. So in order to get pure acid, we do not use volatile acid, so we use sulfuric acid, which is not volatile. The temperature of the reaction should not exceed 200 degrees Celsius. Because sodium sulfate formed at higher temperature forms a hard crust which sticks to the walls of the retort and is difficult to remove, although the yield of nitric acid is high. So if you increase the temperature above 200 degrees Celsius, then we can get more nitric acid. The yield of nitric acid will be good, but then also sodium sulfate or potassium sulfate, whatever is formed, okay, whatever is formed will have a hard crust which sticks to the wall of the retort and cannot be removed easily, so which can break the retort while removing that. The higher this is the reaction that takes place, okay, at a higher temperature. At lower temperature, here will be sodium hydrogen sulfate and potassium hydrogen sulfate, but at a higher temperature you can get sodium sulfate and nitric acid, and here also same thing. Then the higher temperature may damage the glass apparatus, and at higher temperature decomposition of nitric acid can also occur. That means huge amount of nitric acid will decompose, and this is wastage of fuel. So what should be the temperature while preparing nitric acid in lab? Below 200 degrees Celsius. Then manufacture of nitric acid. Manufacture of nitric acid. A German chemist Ostwald in 1914 developed Ostwald process. The process is explained in 3 steps. Step 1, catalytic oxidation of ammonia. Catalytic oxidation of ammonia. In step 1, here regarding this manufacture of nitric acid, we need to deal with the equations only equations with conditions where applicable. So we will not go in detail regarding the procedure, so we'll go for the equations. So this step number 1 for the preparation of nitric acid using Ostwald process is catalytic oxidation of ammonia. So while catalytic oxidation of ammonia gives us, yes, catalytic oxidation of ammonia gives us nitrogen and water vapor, whereas catalytic oxidation of ammonia gives us nitric oxide and water, and which on further oxidation gives nitrogen dioxide. A mixture of dry air free from carbon dioxide and dust particles and dry ammonia in the ratio of 10:1 by volume is first compressed and then passed into the catalytic chamber containing platinum gas as catalyst at about 800 degrees Celsius. So this is the apparatus set up for preparing nitric acid by using Ostwald process. This is the chamber where platinum catalyst is there, and 10 volume of air is passed and 1 volume of ammonia gas. That means the ratio is 10:1. Air 10 volume, if you are passing 10 volume of air, if you are passing 10 liter of air, then you have to pass 1 liter of ammonia gas through this into this chamber. And this is the platinum catalyst which on heating gives us reddish glow. Then this is at 800 degrees Celsius, and this is a catalytic chamber. Then here is the heat exchanger, okay, heat exchanger, and the gas formed will go here, okay, here. The gas is hot, so it is cooled by passing water, and then the supply of air is there. Yes, then again here is the supply of water. Then this is oxidizing chamber, and then again the vapor whatever is formed is cooled here, and finally we are getting nitric acid. So this is absorption tower. This is what? Absorption tower. So this results in the oxidation of ammonia into nitrogen monoxide, nitric oxide. So ammonia plus oxygen in presence of platinum, that means catalytic oxidation of ammonia at 800 degrees Celsius gives nitric oxide plus water plus heat. The reaction is exothermic, and the heat evolved maintains the temperature of the catalytic chamber. Then in step 2, what is the oxidation of nitric oxide in oxidation chamber? So in this oxidation chamber, this is oxidizing chamber. So in this oxidizing chamber, what happens? Nitric oxide Okay, nitric oxide converts to converts to nitrogen dioxide. Nitric oxide here nitric oxide converts to nitrogen dioxide in oxidation chamber. Oxide combines with oxygen to form nitrogen dioxide at about 50 degrees Celsius. So this is nitric oxide combines with oxygen at 50 degrees Celsius to give nitrogen dioxide. This is step number 2. That means in step number 1, what will happen in step number 1? Ammonia combines with oxygen in presence of platinum at 800 degrees Celsius to give nitric oxide. And in step 2, in oxidation chamber, nitric oxide combines with oxygen at 50 degrees Celsius to give nitrogen dioxide gas. And then in step 3, absorption of nitrogen dioxide in water. That means nitrogen dioxide is absorbed. Nitrogen dioxide is absorbed in water. You can see here. What happened here is the air and ammonia gas is passing, and then here nitric oxide is passed, and this nitric oxide is cooled here. Nitric oxide is cooled here. Okay, this nitric oxide is cooled here, and then this nitric oxide is further combined with air. Then nitrogen dioxide, we will get nitrogen dioxide, and this nitrogen dioxide is cooled here. Then this nitrogen dioxide passes here. Then this nitrogen dioxide is absorbed here with water. That means nitrogen dioxide combines with water. And when nitrogen dioxide combines with water, we get nitric acid. We get nitric acid. So in this way we get nitric acid. So the nitrogen dioxide and oxygen present in the air. The nitrogen dioxide and oxygen present in air react with water to form nitric acid. So 4NO2 plus 2H2O plus O2 gives nitric acid. The nitric acid obtained at the bottom of the tower is concentrated above 50%. The above acid on further distillation gives 68% nitric acid. This acid is concentrated nitric acid which is used in laboratories. So whatever acid we obtained is concentrated above 50%, which on further distillation gives up to 68% concentrated nitric acid. So this way we prepare nitric acid using Ostwald's process. And regarding this, you need to go through these chemical equations and the conditions. So again, let me repeat again. In step 1, what we do, we pass 10 volume of air and 1 volume of ammonia gas through catalytic chamber, where platinum catalyst is there, which is kept at 800 degrees Celsius. And what happened is in this ammonia combines with oxygen and forms nitric oxide, and this nitric oxide further reacts with oxygen in oxidation chamber and form nitrogen dioxide, and then this nitrogen dioxide is absorbed with water in absorption chamber. Then nitric acid is formed along with oxygen from air, and the nitric acid that is obtained at the bottom of the tower, of the absorption tower, is 50% concentrated, which can be further improved by distilling nitric acid again up to 68%, and this is the acid, concentrated nitric acid, which we use in laboratories. Then this is the flow chart for the Ostwald process. So you can see here dry ammonia gas 1 volume and dry air 10 volumes, dust-free, goes to catalytic chamber. And this is the reaction that takes place in catalytic chamber. 4 molecules of ammonia combines with 5 molecules of oxygen at 700 degrees Celsius to 800 Celsius. So this is the flow chart for the Ostwald process, and from here dry ammonia, 1 volume of dry ammonia is passed, and from a mixture of dry ammonia of 1 volume and dry air of 10 volume is passed to this catalytic chamber where there is platinum, and the reaction that takes place in this catalytic chamber is this. This is step number 1 for Ostwald process. And then this is the heat exchanger which exchanges this heat in converting nitric oxide to nitrogen dioxide at 50 degrees Celsius, and this is step number 2. And this nitrogen dioxide that is prepared in oxidation chamber is passed to absorption tower where it combines with water and oxygen to give nitric acid, and finally we get nitric acid. So this is the whole Ostwald process shown in this flow chart. And then some of the chemical properties of nitric acid as an oxidizing agent. Oxidizing agent means the substance that can add oxygen, that can either remove hydrogen or can remove electron, so is oxidizing agent. Now carbon as a non-metal combines with nitric acid and gives carbon dioxide and water and nitrogen dioxide, whereas when it reacts with sulfur it gives sulfuric acid, water and nitrogen dioxide. So the difference you can see is when carbon combines it gives carbon dioxide, when sulfur combines it gives sulfuric acid. Rest of the products are same: water and nitrogen dioxide, with carbon gives carbon dioxide, with sulfur it gives sulfuric acid. And then when copper combines with cold and dilute nitric acid, it gives copper nitrate plus water plus nitric oxide, whereas when it reacts with concentrated nitric acid, then you will get nitrogen dioxide. If you compare these two reactions, then rest of the things are same. Reactants and products are same, except here with dilute you get nitric oxide, and with concentrated you get nitrogen dioxide. And you may be confused here with hot dilute nitric acid. Hot means when you start heating dilute nitric acid, then water present in dilute nitric acid will become less, which converts into water vapor. Means if the volume of water decreases, means volume of concentration of nitric acid will increase. As a result, concentrated nitric acid is equal to hot dilute nitric acid. So with hot dilute nitric acid or concentrated nitric acid, copper gives nitrogen dioxide. With dilute and cold nitric acid it gives nitric oxide. So this is the end of this chapter. This much for today. Thank you.